Good evening. This is the last one for tonight. But again, if you want me to do any videos, don't hesitate to let me know. All you got to do is you got to send me a screenshot. That's all you got to do. There's a couple of different equations that you can look at for this. Probably what makes this difficult is you have to decide if you are doing exponential growth or if you're doing exponential decay. Okay, and so that's something that we want to look for when we read the word problem. So it says there was a sample of 700 milligrams of a radioactive substance to start a study. Since then, the sample has decayed, okay, by 2.6% each year. Let T be the number of years since the start of the study. Let Y be the mass of the sample in milligrams. Write an exponential function showing the relationship between Y and T. So the first thing that we're doing is we're just showing the relationship. We're just showing the relationship here. So 700 milligrams, that's what we started with. Okay, that's what we started with. So we're gonna have a Y right here. Okay, so let's kind of think of, I'm gonna do f of t is kind of what we're doing, f of t right here. Okay, so then we're gonna have Y, which is going to be the mass of the sample in milligrams. Okay, T is going to be the number of years since the study started. Okay, so what we have to decide right here, this is going to be our rate right here. We have to decide if we are going to do 1 plus 0.026, and we'll talk about that in just a second, or if we need to do 0 minus. Okay, that's the big thing that we have to decide. Do we need to do plus or do we need to do minus? Then our T is going to be right there. Okay, so we had f of t equals Y, which is going to be our 700 milligrams. Then we're going to have 1 minus the rate that we were given, or we're going to have 1 plus the rate that we were given. And then it's raised to T because T is the number of years since the study. Now, I want to talk about this 2.6% each year. 2.6% each year. Okay? That is a percent, and any time that you are doing anything algebraically, you have got to turn that percent into a decimal. You have to. Okay? So we're going to move that over 2 spaces right there. Okay? So 2.6%. We move that decimal 2 spaces, and as a decimal, that is 0.026. That's the rate, okay? So like I said, we've got to decide if we are adding or if we are subtracting that. When we have the word growth in our problem, that is when we add to 1. When we have the word decay in our problem, that is when we subtract. Growth means it's growing. You are going to get a bigger number. You have more than 100%. Okay? Decay means it's dropping. So you need to have a number less than 1 right here. Okay? So we have the word decay in our word problem, so we have to have the minus. Okay? So now we're going to plug some of these things in. So we've got f of t. We know that our starting point was 700 milligrams. Okay. Then we know that we're subtracting. So I have 1 minus 0.027. Think about it the same way. So if I had this still as 100%, I would say 100% minus 2.6%. Okay? We're still doing that. We're just doing it in decimal form. So I have the whole number 1 minus 0.026. And when I subtract that, I am going to get 97.4. Okay? And 97.4 as a percent, and remember, we want everything in decimals, is 0.974. Okay, so that's what's going to go right here. Okay, and we are going to raise it to the t power. And I think it asks for 2 years, right? Okay, it did not. It just wanted the equation, and that's the equation right there. We just have to put our t right there. Now, eventually, I think it did ask. Well, you could. So if it was asking for a specific year, like 3 years, you would have f of 3, and so you would plug 3 in for that t. Okay? Now, it's super important that you understand keystrokes, calculator keystrokes. And this is just an example right here. Your answer to the problem is this right here. That's your answer. But if you took it further and you wanted to know, your keystrokes would be 700. Then you would have a parenthesis. Then you would have 0.974. Then you'd close that parenthesis. Then you'd put a caret top right there. That caret top means that you're raising that to the third power. That's what your calculator keystrokes would be. I actually don't have a calculator pulled up, so give me just 1 second. So I've got 700 times 0.974. I have to close those parentheses, and I am raising that to a power of 3. Now, should we have a number larger than 700 or smaller than 700? So think about that. Should I have a number bigger than 700, because that's what I started with, or smaller than 700? And then I want you to think about why. Why should it be bigger or why should it be smaller? Okay. Good. I hope you said that you should get a number smaller. Okay. And the reason that the number should be smaller is because of that word decay. We are talking about a decay situation. Okay. If we had said growth, if we said it was a population growth problem, an exponential growth problem, then the number would be more. But it's not. So when we did this in our calculator, and you were not asked to do this in your calculator, but if you were, you would get 646 and 0.8 of a milligram. Okay? Again, if you have any questions, let me know, and screenshots are super helpful.